Okay, so this is sheet 17. So we have two kids pushing a box. One's pushing at 51 pounds, the other one's pushing at 40 pounds, and the resultant forms an angle with the 40 pound at 33 degrees. Fine. We want to find the resultant force. Alright, so we have what looks to be a law of sines problem here, but it's really not. What we need to do is, since we know this is 30 degrees, we need to first find this angle. Okay? Once we find this angle, we'll call this y. We'll then be able to find this angle, z, and then we'll find x. Alright, so what we have is 51. Oops. Let's move this down. So we have 51 over sine 33 equals 40 over sine of x. Sine of y, I'm sorry. So we get y equals, because that's all we need for that. And we're going to go to our calculator. And so we have 40 sine 33 divided by 51. Good, now we're going to do second sine of that value. Oh, looks like we're in the wrong mode. So let's go down to the degree mode. Alright, there we go. And now we're going to go to second sine of the answer. And we get 25.28 degrees. 25, we'll say 25.3. So that means that we have an angle left for y. So we have 180 minus 33 minus the 25. I'm going to keep the answer to a couple of decimal places. 2796. Good. And so that means that the angle z, let's put this as always on top, 121.7. So z, 121.7. So now we have x over sine 121.7 equals, we'll stay with the 51 over sine 33. And again, now we just do a quick little cross multiply for x. Bring this over here, so we have 51 sine 121.7 divided by sine 33. And you get 79.6. 66, so 79.7. Good. Alright, so Mr. Callahan asked GameStop in his hometown, Wii consoles they have sold each year. So this is going to represent year 0, year 1, year 2, year 3. Write a linear regression, so we do that, so we end up with y equals negative 35.5x plus 457.5. Now this is our correlation coefficient, is the R right there, and we need to know that. Does the correlation make sense? Yeah, the values are going down considerably, so yes. The values keep decreasing. That's basically what that's saying. And if we're going to project in 2017, so that's going to be 9 years. Nope, sorry, 10 years. So in 10 years we have 102.5, so 103. Good. Alright, Facebook hit 1,000 users. You began logging in the numbers, so we show you that we did that. Write an exponential equation, rounding to 4 decimal places. Okay, so we have that come up here. We did that all through the calculator, so we have y is equal to 999.9725 times 1.0493 to the x. Does the correlation coefficient make sense? Yes, it does. Okay, we keep increasing in value. Alright, and 6.5 minutes after the time started, so the 6.5 minutes is going to be right here on our table. So we should have 1366. We don't have the 0.8 user yet. That doesn't happen until after that. Good. Alright, the amount of caffeine remains in your system after drinking a single tablet indicated by the time below. So we take this, put it in our lists. You can see I'm using L3, L4 now. We write a power regression for the set of data, so we're taking that value right off of the power regression chart on our calculator. So now we have y is equal to 42 points. Now we want nearest 10 thousandths. So that's tens, hundreds, thousands, 10 thousandths, 4 decimal places. So 2, 3, 2, 6 x to the power of b, which is negative 0.4494. Good. Correlation, yeah, we keep going down, so yes. As caffeine, as the time expires, the caffeine diminishes. And using the equation predicted caffeine after 5 days. Well, 5 days, so just remember it's 5 times 24 hours. So that's going to be 20, right? So it's 120 hours. It's right there. So we have 4.9. Good. All right. Logarithmic regression. Logarithmic is ln. So just you have to remember that this is the ln regression for us. So we did it last again. This is our L1 list, our wind. Oh, never mind. Wind. And this is the chill. I should say this is speed. Good. So we do that. So when we do that, we have y is equal to 13.0134 plus, or I should say minus a negative 7.3134. That's 5. Got around ln x. Okay. Wind chill factor. Now the wind chill factor is the y. 50 miles per hour, so that's our value, so it's going to be negative 15.6. Wind chill factor is 0, so that's happening somewhere here, right? Somewhere between 5 and 10. So that means we have 0 equals. Let's go back up. Let's see if I can grab this. Like that. There we go. There we go. Alright, so now we have 0 equals 13.0134 minus 7.3135 ln of x. So now we have negative 13.0134 is equal to negative 7.3135 ln of x. We have to divide that. So we get 13.0134 divided by 7.3135 gives you 1.7, so 1.7994 equals ln of x. And now we put both to the power of e, so we get e to that value is equal to x. So bring back up the calculator, so now we're going to go to e of that answer. And we get 5.9261. So 5.9261. Good. Done. Alright, here we go. Mid-September, statewide average gas prices in dollars per gallon. Table below. So here we go. That's a linear regression. We have the table. So again, you have the y equals 0.0834x plus 1.259. The actual, using the equation, determine how much more the actual 2005 predicted 2005. So 2005, so that's the 5th year. So at year 5, we have 1.67, we'll say 1.676, and 2.956. We're going to subtract them. So 2.956 minus 1.686 gives, well, sorry, I missed the decimal point there. .7. 1.27. Good. And I believe this should be the last question. Here we go. We have our table. There's your exponential. Again, you can write that on your own. Using the equation, predict cubic meter for temperature 50. And that's answer right there. And again, according to our table. Good. I'm running out of time. Last question, you have your power regression is right here. You have your table for 15 minutes. You have another question. Here's your thing. Here's your linear regression. Before the 2009. Here's 2009. And here's 2%. Good. All right. So time's up. Have a good day. Why isn't it stopping?